Hello everyone, welcome to Toppscholars, the smart learning app. Today in this lecture, we are going to discuss something really important. Today, we are going to discuss the last 5 years of questions from the Maharashtra State Board examination for 10th standard. So if you are studying in 10th standard in the Maharashtra State Board, this lecture is very important for you. Today, the chapter that we are going to discuss is lenses. Okay, so let's start with our lecture, and first of all, let's see how many questions for different marks were asked using this chart. Okay, so now look at this chart over here. We can see here in the last 5 years there have been multiple questions that have been asked from this chapter. You can see there have been some questions for 1 mark, 2 mark, 3 mark as well as for 5 marks. So in the year 2019 we had one question for 1 mark, one question for 2 mark and one question for 3 marks. Then over here we have one question for 1 mark and we have got one question for 5 marks. Then here in the year 2021 we have one question for 1 marks, then one question for 2 marks and one question for 3 marks. Then here in the year 2022 again we can see one question for 1 marks, then one question for 2 marks and one question for 3 marks. Similarly here 2023 we have one question for 1 mark and one question for 5 marks. In this way we have got total 5 questions for 1 marks, then 3 questions for 2 marks and 3 questions for 3 marks and 2 questions for 5 marks. So that means in total we have got 5 plus 3 plus 3 plus 2. That means we have got how many? 13 questions, isn't it? Total 13 questions have been asked in the last 5 years, okay, from this same chapter. And how much marks did they carry? 5 plus 6, 11, 11 plus 9, that is 20, and 20 plus 10, we have got 30 marks, right? So that means overall we have had 30 marks of questions asked in the last 5 years, right? We can see here total 13 questions were asked. That means this chapter carries a lot of marks, isn't it? And this chapter is definitely important for us if we are preparing for the 10th standard board examination. Now let's have a look at this same data in another way, right? This is a graph which is indicating the same data in the graphical form. Okay, you can see over here in each year 2019, 20, 21, 22 and 23 how many numbers of questions for different marks were asked, isn't it? Like this blue color, it indicates 1 mark questions, orange color it indicates 2 mark questions, and this gray color it indicates 3 mark questions, and this yellow color it indicates 5 mark questions, right? Now let's actually get into those questions and let's see which questions were exactly asked in the last 5 years, starting from the year 2019. Okay, now before we start, I just want to tell you that over here we are going to look at every question that have been asked, but we are going to have a look at detailed solution of some of the questions from these multiple questions. Okay, but yes, definitely we are going to discuss each one of these questions in short, but at the end of this lecture we are gonna discuss in detail solutions to the some of the important questions. Okay, so let's start with our lecture now and let's see what are these questions. First, starting with 2019, first question over here: state whether the given statement is true or false. This is a very short answer question for just 1 mark, right? So here the statement is a concave lens is a converging lens. So definitely this is a false statement, right? Because we know concave lens is a diverging lens, right? So this is false. Moving on to the next, from the 2019 again, the question is observe the following figure and complete the table. So this is the figure. You can see we have got a convex lens, that is a converging lens, This is optical center O. Here it is the object AB, and here we can see the focal or the principal focus. This is 2F2, this is F1, this is 2F2, and we can see that the object is between O and F1. Right now, definitely in this case, what happens is the image which is formed is on the same side. It is virtual and erect, and it is always magnified. Right. So here we can see a magnified erect image is formed on the same side. Now, using this diagram or using this figure, we have to answer some of the questions, or we have to complete the table. Okay. So let's look at the table. So this is the table. Okay. Observe the following figure and complete the table, right? So position of the object, okay, position of the image, size of the image, nature of the image, isn't it? So over here we have to complete this table, right? So here position of the object, we know the object was between O and F. So we have to write here between O and F. Then position of the image, it is on the same side as that of the object. So here we have to write that. Then size of the image. So size of the image, we can say over here that it is magnified. Here nature of the image. So it was a virtual, okay, and erect image. So all these things we have to write, isn't it, for this question. Okay. Now moving on to the next. Here it is. So here the question is somewhat like this. Surbhi from standard 10th uses spectacle. The power of the lenses in her spectacle is 0.5 diopters, right? Answer the following questions from the given information. Okay, so what are the questions? Identify the type of the lenses used in her spectacle. Okay, so which type of lens is used? So it is simple, right? Since the power is positive, that means it's a convex lens, right? Then identify the defect of vision Surbhi is suffering from. So definitely convex lenses are used for hypermetropia. So that must be the answer for this question. Then find the focal length of the lenses used in her spectacle. So we can find out focal length by using the formula 1 upon power. So just put this over here, you will get the answer, right? So F will be equal to 1 upon 0.5 diopters. So when we put it diopter, it becomes meter. Okay. So this is going to be the answer. So 1 upon 0.5 is definitely equal to 2 meter or 200 centimeters, right? So this is the answer. Moving on to the next question. Okay. For the normal human eye, the near point is at what? So option is over here 25, right? The 4 options are given: 10, 20 centimeter, 25 and 30. So for a normal human eye, it is found out that the near point is at 25 centimeter. This is the standard number used everywhere, right? Because most of the people will have their near point at 25 centimeter. Yes, more or less it will be, little bit more or less, but on an average the number is 25 centimeters. Okay, moving on to the next question. Okay, so this is from the year 2020. Draw a scientifically correct labeled diagram of a human eye and answer the questions based on it. Okay, name the type of the lens in the human eye. Name the screen at which the maximum amount of incident light is refracted, and then state the nature of the image formed of the object on the screen inside the eye. So here what we have to do is scientifically correct labeled diagram of human eye. That is what we have to draw. Okay, so we are going to discuss this question, okay, in detail later on, okay, at the later stages of this lecture. Okay, so right now let us not discuss this. We will definitely discuss this later. Okay, moving on to the next question from the year 2021. Okay, complete the correlation. Object at unlimited distance. That means object at infinite distance. So point is at focus F1. Okay, then object between F1 and 2F1. So when the object is between F1 and 2F1, then the point or the image is formed beyond 2F2, right? Then, so this should be the answer. Okay, and this is a very short answer question for 1 mark. Okay, so this was the simple question asked in 2021. Okay, so it is very simple. Here just we have to find out the correlation. Just like when the object is at infinity, then the image is formed at the focus. Similarly, when the object is between F and 2F, then the image is formed beyond 2F. Okay, next question is, write a note on persistence of vision. Okay, so this is a short answer question for 2 marks. Now, here you have to write a short note. Okay, so you have to talk about what is persistence. So what happens basically is, whenever you are looking at some object, like right now you are looking at the screen, then whatever you are seeing, okay, the rays of light are coming from that particular object and entering your eyes, and they are falling on your retina, and then from the retina there is a optic nerve connected to your eyes into the brain. Okay, then the image is processed by the brain. Okay, now whatever image is formed in your brain, that image stays or persists for a very short amount of time. Okay, and this phenomenon is simply called as persistence of vision. Okay, so this is what you have to explain over here. Next is, distinguish between myopia and hypermetropia. Okay, myopia and hypermetropia. So basically you have to talk about what are these defects, right? These are nothing but the defects in our eyes. Okay, so what is hypermetropia and what is myopia? That is what you have to differentiate. Okay, like for example, hypermetropia is a defect for which we use convex lenses, and myopia is a defect for which we use concave lenses. Okay, so this is what you have to talk about, and you have to write 4 to 5 points for this, okay, to get full marks. Okay, moving on to the next question. This is from the year 2022. The power of a convex lens of focal length 25 centimeter is what? This is a MCQ for 1 mark. So this is 25 centimeter, that means 0.25 meter, because whenever we calculate power of a lens, we have to take focal length in meters only, and we know power is equal to 1 upon focal length, and it should be 1 upon 0.25, which is 4 diopters, right? So the correct answer over here should be 4 diopters. Then next question is, give reason. Simple microscope is used for watch repairs. Okay, so if there is a person who is repairing watches, okay, wrist watch especially, okay, then that person uses simple microscope. Now basically what is simple microscope? It is nothing but a simple convex lens. A single convex lens, okay, is also called as simple microscope. Okay, now why it is used? Because this simple microscope or this single convex lens has the ability to produce erect and a magnified image of the small objects. Okay, and it can magnify that particular object and it can produce an erect image. That is the main benefit of using this convex lens. Now when does this happen? whenever the object is between F and O, that means the optical center and the focal point. If the object is between these 2 points, then we will get to see a erect and magnified image. Okay, so that's why if you look at the person who is repairing wristwatches, he keeps that simple microscope or the lens very close to the watch, so that the watch is between F and O. Okay, and in that case only he is able to see a magnified and a erect image of that particular watch, wristwatch. Okay, so this will be the reason. So you can show this by drawing a simple diagram also, okay, for the simple microscope. Okay, and this is for 2 marks. Okay, moving on to the next question now. Okay, here it is. From the year 2022 again, complete the following table for convex lens. So here it is, position of the object, position of the image and nature of the image. So here it is, this is for a 3 marks, so it is very important. Now, when the object is beyond 2F, so when it is beyond 2F, then the image is formed, right, between, isn't it? Between F2 and 2F2. Nature of the image. Now, in this case, when it is beyond 2F, then the image is definitely, it is diminished, right? It is real and it is inverted. Okay, so this is going to be the nature of the image. Next, here we can see that the position of the image is given and it is at infinity. Okay, so this basically happens when the object is placed at principal focus. And what is the nature? Nature is the image is basically real, it is inverted, okay, and it is highly magnified. Okay, so this is going to be the characteristics. Next, here we can see it is given that nature of the image is real, inverted and enlarged. So this basically happens when the object is placed between F and 2F, okay, and in this case the image is formed beyond 2F. Okay, on one side if we use F1 and on the other side of the lens we use F2. Okay, so this is going to be the answer for this particular question. Okay, moving on to the next question. Now we are into the year 2023. Okay, that means last year. Now this is MCQ for 1 marks. The power of a convex lens of focal length 20 centimeter is what? So it is very simple. Power is equal to 1 upon F, and 1 upon F has to be taken in 20 centimeter. When it is converted to meter, it becomes 0.2 meters. And P will be equal to 1 upon 0.2 is 5 diopters. So our answer should be option A, 5 diopters, right? So this is again a very simple question. Moving on to the next over here. Observe the figure and answer the following questions. Okay, so here a figure is given. Here is a human eye, right? Okay, and here is the crystalline lens inside our eyes. Okay, here is the cornea. And now you can see all the paraxial rays, that means the rays which are parallel to the axis, they are entering into the eyes, but they are not being focused on the retina, they are focused somewhere here. Okay, so now what we have to do, right? There are certain questions that we have to answer. First of all, name the defect of vision represented in above figure. Okay, so here the person is not able to see the objects which are very far, right? Because all these parallel rays, they are coming from a object which is very far from our eyes. So this person has a defect of nearsightedness. That means he is able to see the objects which are near but not able to see the objects which are very far. So this is basically called as myopia, right? Isn't it? So this is one thing. And basically this crystalline lens is connected with the ciliary muscles over here, is it, which help us in changing the focal length of this particular lens, okay, by either contracting the lens or either just enlarging the lens, okay. So state the reasons for this defect. So one of the reasons for this particular defect is the aging of our eyes, right? Due to aging, sometimes what happens is these ciliary muscles get weaker and they are not able to focus properly, or we can say they are not able to stretch our lens, okay, and that's why they are not able to focus the incoming light at the retina. So this may happen due to that, okay. There are multiple other reasons also. Now how it is corrected? So by using a diverging lens, what we can do is we can diverge all these rays so that all these rays will focus over here. Draw the diagram to show the correction of this particular defect. So over here we have to draw the diagram also. So we'll draw this diagram at the later stages, okay. We'll discuss this question again. So this is for 5 marks, okay. So this is very important question. Moving on to the next. Now what we will do is, these are some of the questions that we have already seen. Now we are again going to discuss, okay, in detail. So the question which was asked in 2019 for 3 marks. Surabhi from standard 10th uses spectacle. The power of the lenses in her spectacle is 0.5 diopter. Answer the following questions from the given information. Identify the type of lenses used in her spectacle. Identify the defect of vision Surabhi is suffering from. Find the focal length of the lenses used in her spectacle. Okay, let's look at the solution. First over here, the power is positive, hence the lens used in Surabhi's spectacle is convex. Next, the defect she is suffering from is hypermetropia, as we had previously discussed. Then the next is power is equal to 1 upon f, and we can calculate this. F comes out to be 200 centimeters, isn't it? So these are the answers to the questions. Okay, moving on to the next question. Okay, draw a scientifically correct labeled diagram of a human eye and answer the questions based on it. Name the type of the lens in the human eye. Name the screen at which the maximum amount of incident light is refracted. State the nature of the image formed of the object on the screen inside the eye. So these are the 3 questions. Let's look at the solution now. So first of all, this is the scientifically correct, okay, diagram of human eye. You can see there are multiple parts of this eye. Like here we can see we have got ciliary muscles, then we have got iris over here, we have got a pupil over here, then crystalline lens, cornea, sclerotic coat, choroid, then we have got some muscles here, then the optic nerve is over here, then optic disc is somewhere here, and this part is retina, okay. So these are the multiple parts of a human eye, okay. Here it is. The human eye's lens is a transparent, crystalline, double convex lens. So first question was which type of lens it is. So this is the type of the lens which is present in our eyes, which is nothing but transparent, crystalline, double convex lens. Next, at the cornea's outer surface, the maximum quantity of incident light is refracted inside the eye. So here, this is the place where most of the light is refracted. This one, the cornea, isn't it? At this place itself, most of the light is refracted. Next question is, the image of the object created on the inside screen of the eye is real and inverted. So next question was where the image is formed and what kind of a image is formed. Okay, so the image of the object is created inside screen of the eye, which is nothing but the retina, and it is real and inverted. So whatever the rays of light are coming, due to this, an image is formed on the retina and that image is real and inverted. Okay, moving on. This is the next question that we had previously discussed also. Okay, so let's look at the solution for this also. So here we have to just complete the table, position of the object, position of the image and nature of the image. Okay, these are the things to be filled over here. This is from the year 2022 for 3 marks. Okay, so let us discuss this. So here it is. Okay, first it is beyond 2f1, so it is between f2 and 2f2 and it is diminished real and inverted image. Next, when it is at focus, image is at infinity and what is the nature? Real, inverted and very large or very enlarged or highly enlarged. Okay. Next is when the object is between f1 and 2f1, then the image is beyond 2f2 and it is real, inverted and enlarged, right? So these are the answers to the given question and this is how we have filled up the data. Okay, so in this way today we have discussed multiple questions that have been asked in the last 5 years, okay, from the chapter lenses in the 10th standard Maharashtra State Board examination. Okay, so today we have discussed multiple questions and I hope everything that we have seen today is very clear and very well understood. So thank you so much for watching and all the best for your upcoming examinations. Thank you so much.